That was right in my ear, man.
Yeah.
Sound check there,
Alright, so my name is Archie Hendryx. Today I'm going to talk about DevOps, which, if anyone's running virtualization, is a key methodology for application lifecycle management, and certainly more key to your business than virtualization being just a tool to consolidate and give you power and cooling savings. This is really where virtualization is heading, and if you're not deploying a DevOps methodology or considering it, you certainly should be today. So what is it? Well, if we look at application lifecycle management, typically what happens, you've got a line of business, you've got product managers who develop these wonderful new products and new ideas for the investors and shareholders of the business that actually have very little technical reality or feasibility, but they promise the business these things are going to get delivered. And then what happens is that then gets handed over to development teams who then have to deliver these new features and applications and have them running into production and somehow make the impossible technically feasible. And then typically when they've done it, they chuck it over to operations who get handed over that application with the code and everything, but has absolutely no way or understanding or knowledge of how to install or configure or manage that application. So then what happens, operations do what I call tribal processes, where you pretty much got a manual guy doing everything. He'll be tweaking his own little database, he'll be doing his own manual configuration, his own scripts, so that it works on a production environment as opposed to how it worked in a development environment. But then he becomes that single point of failure. And then typically once it's out and delayed and eventually gets to the end user will run that application, but how that application performs in terms of response times, in terms of SLAs, Dev will have absolutely no idea, but that'll probably get fed back to operations, and then operations have feeling the pain of making an application perform better. So that becomes a real painful situation for operations. For operations, application releases are a tense, horrible time. It's a time when the business is demanding quick things from them. Development have probably been sitting on an application launch for the last 3 months and then saying the last week, right, you've got to operations run this and have this in production. And all of this is typically done with a lot of risk, and all this is because there's absolutely no cohesion or cooperation between the development, QA and operations teams. And what's making this worse are what we're calling these new Agile Apps. These applications which are on web and mobiles, they're fantastic, but they constantly need to be rapidly and regularly deployed, and they're constantly changing with new features. And if anyone's running application lifecycle management or software lifecycle management on a waterfall method, that long traditional continuous integration process is simply too long and isn't feasible for the new applications of today. So this is what happens. You've got two silos. You've got development and you've got operations. Development's key interests are very significantly different to operations. Development, they're all about pushing for change, meeting the new user requirements, bringing in new features and delivering those features as quickly as possible. Operations, on the flip side, they're all about predictability, availability and stability. So any change is potential risk. They don't want change introduced into their environment. They don't want any potential risk. So you then have this situation where operations and development are not only separate silos, but they're at loggerheads with each other, when actually all they've got to do is work together and get that application released. And then what's worse is that you've got this wall, whether it's metaphorical or physical, between them, where typically dev and operations never even know each other or sit with each other, may even be sitting in a separate continent from each other, but the development teams will be going away busy delivering their code with little, absolutely no involvement with the operations guys, and they'll also be using teams that are typically open source, open and using a lot of flexibility, completely different to what operations are running as their tools, where operations, on the other hand, are more about rigid performance and availability-based tool sets. And again, operations will have absolutely no idea of what development are doing and what tools they're using on how their code is actually being created. So when operations eventually do get that application to be delivered and pretty much it's chucked over the fence to them from development, operations will say pretty much no, and they'll stall that change, because for them, they can't introduce the risk of this flaky application with this new code. So operations will install things because they themselves have to pick up this software release. They don't have to do their own script creation. They don't have to do their own config file editing to accommodate this application code and this application onto their production environment. But then what happens, operations are then seen and visualized as the bottleneck to the business and the application release and these new features, which ultimately causes them to be seen as the bad guys. So what then happens? Well, the problem is there's an inconsistency between what operations are running with and what development are running with. Development will probably have a workstation at best, and when they're running that, they run all the code and test it and validate it and then chuck it over. But then operations will be running on a completely different system, probably a Unix server, a different OS, something with different Java versions, different software load balances, completely different property files, and ultimately it's a completely different environment. And even though they'll then tweak it and change it, when it then goes to run in production environment, it doesn't work, and then the go live fails, and then even when it does go live, you've got a flaky application which isn't performing. And then what happens, that typically comes about from the end user or the customer who's probably on his website trying to click the checkout button and isn't getting any revenue, isn't able to order anything because the web server is down or there's a problem. And then what happens is operations will blame development because they've given them an insecure application, an application that needs constant restarting and is difficult to deploy, while development, on the other hand, will say, no, it worked perfectly fine on our workstation, it's operations, you're incapable of scaling this out into a production environment, hence it's your problem. So DevOps has come about, it's a new methodology, but it's a very straightforward methodology. It's all about collaboration and communication. It's about unifying the application lifecycle process into a comprehensive development to deployment lifecycle, where basically ownership is with each department, from development and operations as a collective whole. So they have a complete end-to-end relationship and ownership for that application release. So what that means is when dev teams start to run their code, they also need to have an understanding of that environmental control they require, and also have a better understanding of what operations are doing in terms of visibility. So if you look at dev guys, for them it's, operations is just a buffet of resource. So hey, I want whatever many gigs and how many terabytes, without actually understanding what operations have got. Internal projects, they've got external projects, they've got change management projects, they've got optimizational projects, they've got net new projects. So development need to understand what operations are doing better, and on the flip side, operations will then also have a better understanding of the application, because right from the offset, they will be involved with the dev team and understanding what the application is, what its requirement is, and how that code is being built, and consequently the infrastructure requirements. So what that means is operations are actually taking part in the development of applications. So when a code is being deployed or created, the environment is concurrently also created at the same time by the operations team. So when dev require a system, they've got a dev system, a QA VM, and a production VM, but that infrastructure is standardized at the same time as the code, so that understanding of the infrastructure requirements is done from day one. And that is then monitored throughout the development to deployment lifecycle as that code is being tested and validated against that infrastructure. And again, the tools will become unified because both development and operations will be using the same tools to understand what it is they are deploying eventually for that application release. Hence, there's a co-ownership of those tools. So that's what DevOps is. It's a co-owned process. The software development and operational maintenance becomes a co-owned process. The finger pointing then becomes eradicated, because if and when there is an issue with the application release, it becomes an ownership for both development and operations, and they have to both feel that sense of ownership, because they have to then work together in that root cause analysis, as operations and development have both worked in that code delivery and that infrastructure. But what you then get is, as soon as code is deployed and infrastructure is deployed at the same time, there's a continuous testing, and then you start to get that automation in place. When that automation starts to take place, you then got repeatable builds that gives you an end-to-end sort of project of restructuring. So any fixes that occur during that lifecycle process, they can be done concurrently by both dev and ops. And the same thing, when these applications are then released, they become far more easier and repeatable and dependable and standardized deployments. And then further on, looking all the way down to the customer experience, when a customer is playing with that app or using that application, regarding response times or SLAs, they can actually feed that back. But it won't just be to operations, it'll also be to development, who can then look at the code and say, okay, how do we need to tweak that code to resolve this application performance, to resolve this application end user experience. So to sort of give you an example, how do we do this with virtualization? Well, virtualization is now seen to be far greater than just virtualizing a bunch of physical to virtual servers. It's all about a self-service portal. It's about a private cloud. So you can have a provider and a tenant, but again, you'll need an infrastructure. Now there's things like converged infrastructure, which come delivered as a standardized product. That will include your storage, networking, and compute, and again, can be upgraded and supported as a single product. And then on top of that, you've got your data protection products that helps you do disaster recovery and disaster avoidance. You can then set up your orchestration tools, your self-service portal, your monitoring tools, your governance and control tools, and as well as that, you can also have your reporting and chargeback tools. But once you've got that private cloud in place, you can start to put the right software. So again, we've got vCenter Operations Manager, vCenter vFabric, vCenter Orchestrator for the provisioning, vCAC and vCloud Director as a self-service portal. You've got Cisco VSG for the security, for example. And then once you get these repeatable builds, you can then start using automation tools like Splunk for the event management, Puppet Labs for the configuration management, Zactium for the incident management. So everything becomes a repeatable build and self-provisioned portal for development and operations to run, which then is also chargeback. It's something that can be resourced, quantified, and also decommissioned at will. So here's an example for a typical DevOps environment. You've got your standardized storage, network, and compute converged infrastructure as your resource pool, which will be patched and upgraded as a single entity. So that removes infrastructure from the headache of the application operations team. But then you set up an autonomous self-service portal for the dev guys to then go and spin up a virtual machine. They can spin up that virtual machine, run their dev test environment. If needed, they can decommission that at will. That resource will then get freed up back into the resource pool, or otherwise that dev machine can then be migrated and moved on into a production environment as part of that standardized repeatable build. But basically they then get a self-service interface which is on a standardized production environment. So to conclude, what does that mean? DevOps is pretty much pushing, with the help of virtualization, dev and test work for development teams to be done in a high fidelity production-like environment that's standardized, self-service and on demand. They don't need to worry now about configuring the application stacks. They don't really care about now about the underlying infrastructure. They can instead concentrate purely on the coding. On the flip side, operations guys like us, they can instead look more around the policies to govern that standardize of application platforms and environments, start to automate more, start to streamline that automation from a pure development to operations lifecycle, as opposed to an application being chucked over the fence to them. And again, as the business demands more from them in shorter time span, because they're automating everything and standardizing those tasks, it becomes no longer a manual configuration, hence you don't have configurational drift. You have everything standardized, quick and operational, and again they have a sense of control and understanding of the resources and what development required for that application. So with that, I'll thank you for listening and appreciate your time, and thanks to the Brownbag guys. Thank you.